Hello, if I may, I would like to bring you the solution of the second task that has been in the last written part of the exam. And more or less, the question was, we have a transmission line composed of two conductors of circular cross-section. The line is 1 kilometer long. At the end of the line, we have a 20 ohm load resistor. And the line is composed of two copper wires, each of the diameter of 15 millimeter. Now we have three questions. First, what is the current density in those conductors, provided that the line is loaded with 1 kiloampere? Second, what is the force due to magnetic field that affects those two conductors? And the third question, what is the input voltage of the line? So first, current density. Well, in order to establish current density, we have to find out the cross-section of the wire. As this is DC, we have the current homogeneously distributed over the cross-section, so we need to know the current and the cross-section. The cross-section is of the shape of a circle. Then the area of that is pi r squared, or pi d divided by 4, which gets to 177 millimeters square approximately. Now, as to the current density, we divide the current by the cross-section and got something like 5.66 ampere per millimeter square. Just comparing that to real life, you have up to 10 amperes per millimeter square for conductors in outer space, in air, and without no harm to the conductors. So you have some losses, but the conductor would not be rather hot. That's correct. Now let's go on. The second question is the force that is given or caused by the currents. First, how that happens? So if we have one conductor fed through by a current, that current, according to Ampere's law, creates a magnetic field intensity, which has the shape of concentric circles. So at the other conductor, we would find the magnetic field running down if the current in the first conductor runs into the board, and let's say the equation for that is that the magnetic field intensity would be I, the current, over 2 pi, and the distance r, which is 2 meters here. Now, as to establishing force, we would rather need magnetic flux density than magnetic intensity, so we would have to multiply that by free space permeability. And we get this quantity for B. Now, we have the conductor that is straight and that is exactly perpendicular to the magnetic flux density. And therefore we could use the easiest equation, which is force is a product of flux density, current, and length. Now putting that into an equation, we get mu I squared divided by 2 pi distance times length. Now it's quite good, before putting that into a calculator, to consider that mu, the permeability of the air or free space, is 4 pi times 10 raised to minus 7 Henry per meter. And we have got 4 pi in denominator, 4 pi in denominator, so in fact we have got 10 raised to minus 7 I square, and length. I is 1000, length is 1000 in SI units, so that gives us 100 Newton, the total force, which the current in the left conductor accelerates on the current on the right, and vice versa. And both of those forces are repulsive, so that it tries to tear off both conductors from the line. 100 Newton is not that much for 1 kilometer, but anyway, you would have to hold somehow on the masts those two conductors. And that's it. Just a reminder, there have been 3 tasks, but the 3rd task is completely contained in my lecture, which is also at this YouTube channel. So, good luck!